All right, the next lesson in geometry is called normal distribution. All right, so his first definition here is normal distribution, of course. A normal distribution curve is a symmetrical bell-shaped curve defined by the mean and the standard deviation of a data set. Okay. Now you should remember that the mean is the average, and standard deviation is a number that tells you how far spread out the data is. Okay. If a data set has a high standard deviation, that means the numbers are spread apart. If a data set has a low standard deviation, then that means the numbers are really close together. Okay. So one standard deviation away from the mean in either direction on the horizontal axis accounts for around 68% of the data, approximately. Two standard deviations away from the mean accounts for roughly 95% of the data. And three standard deviations represents about 99.7% of the data. This is known as the 68, 95, 99.7 rule. Okay, so here's an example of a normal distribution curve. Okay, so if you notice, these two middle sections, 34 and 34, that adds up to 68%, like we talked about above. Okay, if you add on these two segments right here, 13.5, 13.5, so suppose I do 34 plus 34 plus 13.5 plus 13.5, that gives me the 95% number we talked about above. And if I add up these six middle parts, 1, 2, 3, 4, 5, 6, let's see what we get. That gives us 99.7 number we talked about. Okay. So this number in the middle, this is the mean. Okay. Sometimes you'll see it labeled like this. That's the Greek symbol mu for mean. This is the symbol for standard deviation. This is saying one standard deviation more than the mean. This is saying two standard deviations more than the mean. This is saying three standard deviations more than the mean. This will be minus one standard deviation from the mean, minus two standard deviations from the mean, and minus three standard deviations from the mean. Okay. So now we have four examples today, two basic ones and then two more advanced problems. These first two examples are just trying to get you familiar with drawing the curve. Okay? A set of math scores has a mean, meaning an average of 70, and the standard deviation of 8. Sketch a normal curve that represents this distribution. Label the mean and three standard deviations. So here's my curve. Let me draw the horizontal line first. Now let's draw the curve. All right, that's good enough. All right. This right here, this in the middle will be the mean. And I'm going to add three standard deviations in each direction. Okay. So So let's label the mean. That's right in the middle. The mean is 70, so this is the average right there. The standard deviation is 8, so I'm going to add 3 standard deviations. So if I do 70 plus 8, that gives me a 78. Plus 8 again gives me an 86. Plus 8 again gives me a 94. And then let's subtract 8 on each side. So subtract 8, that'll give me 62. Subtract 8, that'll give me 54. Subtract 8 again, that'll give me 46. So this class did not do very good on the test. Anytime you have an average on a test of a 70, it's not a good sign. Okay. So, and what I'm also going to do is I'm going to label the percentage of each section. So let's say this is 34 and this is 34, and these are numbers you're going to want to memorize. 13.5, 13.5, 2.35, 2.35, 0.15, and 0.15. Notice how all those decimals under the curve add up to 100%. Okay. And that's all you have to do for that one. Like I said, this was just an intro problem. What we're going to do later is we're going to have to answer questions based off of the curve. Okay. All right, let's do one more. The heights of basketball players in the basketball league are normally distributed with a mean of 6 foot 1 inch and a standard deviation of 2 inches. Sketch a normal curve that represents this distribution. Label the mean and 3 standard deviations. Okay, so same thing. Let's draw the curve first. Do as best you can. Not good enough. Let's label 3 standard deviations in each direction. All right, so the average height of a basketball player is 6 foot 1. So that'll be right here. Standard deviation is 2 inches, so let's add 2 inches in each direction here. And then I'm going to subtract 2 inches in the other direction. So if I subtract 2 inches, that brings me down to 5 foot 11. All right. And let's subtract 2 inches again, 5 foot 9. Subtract 2 inches again, 5 foot 7. And then let's label the percentages, 34 and 34. $13.5 and 13.5. 2.35, 2.35, and then 0.15 and 0.15. Okay. All right, next page. A calculus exam is given to 500 students. The scores have a normal distribution with a mean of 78. That's a little better than example 1. And a standard deviation of 5. About how many students have scores between an 83 and an 88? Okay, so let's draw the curve first. That might have been a little too big, but whatever. It's just an approximation. Good enough. All right, so the mean is 78. It's going to go right here. Standard deviation is 5, so we're going to add 5 to that, and we'll do it again. And we'll do it again. And we'll subtract 5 in the other direction, so 73. Do it again. Do it again. And then let's label the percentages, and then we'll answer the question. All right, so this has a question we have to answer about how many students have scores between an 83 and an 88. Okay. So that is, I'll get some color. I'll add in some color for this one. It's going to be this section right here. Okay. Now, if I said what percentage of students scored between an 83 and an 88, the answer would be 13.5%, but that's not the actual question. Well, let me just jot that down so you see what I'm doing. I'm going to say 13.5% of students scored between an 83 and 88. So what I'm going to do is I'm going to take 500 because there's 500 students that took the exam. And I'm going to multiply that by 13.5%. Okay. But again, you're not going to do times 13.5. You're going to do times 0.135 because you have to divide it by 100. Okay. If you don't do that, you're going to get a really big answer like 6,750. That makes no sense because there's only 500 students that took the exam. That'll give me about 67.5. Remember, this is an approximation. So I'm just going to round that. I'm going to say about 68 students scored between an 83 and an 88. That'll be my final answer. About 68 students. Okay, last example. The speeds of cars on Post Road have a mean of 55 miles per hour with a standard deviation of 5 miles per hour. Okay, so I left the space over here so you can draw the curve. So let's draw the curve over here. Same thing as before. Label the mean and 3 standard deviations in each direction. The mean is 55. The standard deviation is 5. So 60, 65, 70, 50, 45, 40. And let's label the percentages. 34, 34, 13.5, 13.5, 2.35, 2.35, 0.15, 0.15. Part A, what percentage of cars traveled more than 55 miles per hour? Well, you can always add up all those sections. So let's do that. More than 55. This one, plus this one, plus this one, plus this one. 34 plus 13.5 plus 2.35 plus 0.15, 50%. Well, you should probably know that one right away because it's the halfway point. So 50%. What percentage of cars average between 50 and 60 miles per hour? Just add up these two sections. 34 plus 34 is 68%. What percentage of cars traveled more than 65 miles per hour? Add up these two at the end. 2.35 plus 0.15, 2.5%. If a police car stopped cars that were going more than 65 miles per hour, how many cars would they stop if there were 1,000 cars on the road? So we're going to do 1,000 times what percent is more than 65 miles per hour? Well, we just talked about that in part C, but in case you forgot, I'm adding up these two sections at the end. That gives me 2.5%. Divide that by 100 to get a decimal of 0.025. And you're going to do 1,000 times 0.025. It'll be about 25 cars. Okay. And that's the end of that lesson. That lesson was called normal distribution.